Somewhere in the universe, a star dies. Not quietly, not gently, but in an explosion so powerful, it outshines entire galaxies. This is a gamma ray burst, the most powerful explosion ever discovered. For a few seconds, it releases more energy than our sun will produce in its entire 10 billion year lifetime. And it happens in silence. There are two main ways this cosmic catastrophe begins. The first is the death of a giant star. When a star at least 20 times heavier than the sun runs out of fuel, gravity wins. The core collapses in an instant. A black hole is born. But the collapse doesn't just create darkness. It creates twin jets of pure energy blasting out from the star's poles at nearly the speed of light. If one of those jets points toward Earth, we see a gamma ray burst. For a few terrifying seconds, it becomes the brightest thing in the observable universe. The second way is even more violent. Two neutron stars, ultra-dense stellar corpses, spiral toward each other. They collide. Space itself ripples. And again, a focused beam of gamma radiation shoots across the cosmos. Not wide, not scattered. A narrow, deadly beam, like a cosmic sniper shot. Gamma rays are the highest energy form of light. They carry millions of times more energy than visible light. You can't see them. You can't feel them coming. But they can sterilize entire planets. And because the energy is focused into tight jets, when that beam hits something, it hits with unimaginable force. Most bursts happen billions of light years away, so we are safe. Now imagine this. A massive star within our galaxy collapses. Its jet is perfectly aligned with Earth. The burst reaches us. In seconds, our atmosphere begins to change. Gamma radiation tears apart nitrogen and oxygen molecules. The ozone layer collapses. Without ozone, the sun's ultraviolet radiation floods the surface. Plants begin to die. Ocean ecosystems collapse. Food chains break. Mass extinction begins. Scientists believe a gamma ray burst may have contributed to past extinction events on Earth. If a close burst hit us directly, it wouldn't instantly vaporize the planet. But it could slowly strip away life, not with fire, not with explosions, but with radiation and ecological collapse. The good news, it's extremely rare. Most gamma ray bursts occur in distant galaxies, and the odds of one pointing directly at Earth are very low, but not zero. The universe is vast, violent, unpredictable, and somewhere right now, a star is collapsing. Somewhere, a beam of gamma radiation is racing across space. For billions of years, it travels silently, until one day, it reaches something. Gamma ray bursts are reminders that the universe is not just beautiful, it is powerful beyond comprehension, and sometimes deadly.